So let's talk about methods, also known as functions. We'll talk about the difference between the naming, but really in Java or in much of your career, you'll notice interchange. People will talk about the two words as interchangeable as possible. If we come into other languages, we'll see a difference. For now, let's go and understand why we want these methods or functions inside our application. First thing we got to understand is the reason behind it. The methods and functions are there to make our code much cleaner, much more reusable. So there's a couple reasons we want to use it. You got to also understand that the computer, the compiler, the application that's running your stuff, does not care for that. It actually replaces all of those methods, functions you call with the actual code for it. So what is the reasons that we're utilizing methods or functions? Well, the first one is that it makes our code much cleaner. When we create code between our two parentheses, our entry points, we put in our algorithm, which is a step-by-step solution or step-by-step, I forgot the word I'm looking for, but we're doing steps of statements one by one to reach the end result that we're looking for. This is what we call an algorithm. We're doing steps to be able to do something. And all of these steps will be within these two curly braces mentioned. So our application ends the moment it reaches line 6, because that's the closing statement of our application. Now, what we need inside the algorithm or inside that main curly braces is the general idea, not how it's being executed. So what we're looking for is more like the general things you need to do. Such as if I wanted to visit my students, I don't need to mention that I took the bus and I paid $3 to get in the bus and so forth, so on. I need to mention I went to their house, I looked at the problem they had, I fixed it, resolved it, talked to their parents, and left, right? More than that is not required. How did I get there? What did we discuss, etc. is not the purpose of our main algorithm. So these are more like subtasks. They're still required, they still needed, but we don't need to pollute, let's say, that's probably the correct-ish word, pollute our main algorithm between line 4 to 6. And by making these sub things, we could have an easier time reading our code and coming back to it. And if ever we need to have more details, well, we could go into one of these methods, these functions, and see what's going on, right? So we're going to see some examples of that later on. But that's the first idea, that we want to clean our code by making sub-methods that would do our required task. A great example would be I need the age of the user, and I need to make sure it's between, let's say, 18 and 55. I don't need to see how you code that. I just need to see a word that represents that, and we'll do that in a little bit. Number 2 is we want the code to be reusable. So let's say we have limitations on what I need to see for my inputs. Well, that limitation is not only for one thing, it most likely will be for other things. So we could create these methods that could be reusable for variations of things. Until the general idea is the same, but we don't need to change the code too much. And again, we'll come back to this, but this is the second important thing. And lastly, or at least at our level, lastly, what we want to talk about is context. If we put all our code into this main that we have so far, this is also a method, this main, we're going to talk about it further. If we put all our code in there, it's going to get bloated. It's going to get so much stuff in there. Sometimes you create variables and they still exist. And maybe you needed it at the beginning of your application, but later on you do not need it. So the problem with that is those variables that you created, those things that you created, whatever they are, they stay throughout your application. So what we could do is when we create it inside one of these methods, they will only last or they will only live until the method lives. The moment the method is dead, the moment the method is stopped, those variables are also destroyed. The same way, the moment our application is closed, well, anything we created or done inside is also gone with it. So this is an important key to grasp. Obviously, there's a lot of other things I didn't mention, especially if you're coming from a background already knowing this. Another good point would be probably security. We could test out our code. If we make it smaller, we could make better tests for it. Okay, but we'll come back to those more complicated stuff a bit later. So what can we do with this? Let's go ahead and first erase a little bit here. What can we do with this? So let's go back to our previous code, our previous video, where we talked about arrays. And inside of this, let me clear my screen a bit. Inside of this, we did a couple things. The first part is we asked how many students there were. Then when we got that total, we needed to get the grade for all those students, right? And then after that, we needed to print every student. Well, the thing is, it's not a big algorithm, but there's 3 main steps in there. And if we wanted to, we could create methods to do those steps and not have to repeat ourselves. So what do we need to do to make these steps happen? So these steps, they're going to start with figuring out what is the purpose of our application. What is, not our application, sorry. What is the purpose of that method? Is it to do this or is it to do that? In this case, let's take an example over here. Here, our purpose is to print every student and their grade. So that's our purpose. This is important to understand our purpose because they will decide what we're going to code. The next step is to understand the input required for that to function correctly. Well, in this case, you would say, well, we don't need an input. We have our student's grade and so forth, so on. But what we want to do when we create these functions, methods, we want to kind of make them as independent as possible. So there's a limitation. Later on, when we learn about objects, we'll come back about this independence. But for now, we want to normally make something as independent as possible. Next step is to figure out what the outputs would be. Is it outputs going to the console, or is it outputs going back to the person that called your method? And this is, again, another important part. So let's say if he gave me the grades, what am I giving back to him? Well, in this case, the purpose of our application was to print to the screen. So we don't need to give back anything to the caller, but we do need to output to the console. And lastly, which is not really lastly, but lastly is we need to figure out what are the steps to make that happen. And to be honest, that last step is basically our first step, is the purpose. The purpose is the end goal. The last step, the mini algorithm, is the steps required or taken to reach that purpose, that goal. So let's see how that would function for us. So to create a method, to create a method, first of all, you'll notice that we already have one method here, right? This thing that we see here is a method, and this is the body of the method, this curly braces, right? And we're going to talk more about it. Over here is what we call a method signature. And there's a few keywords that's important to us, and we'll come back to that over many times. But for now, what's really important for us is to have a good name, this part. Actually, let me draw some stuff here. So we have a good name. The name defines what it's doing. So this is important. And we're going to talk about how to name a little bit later. The input is defined by this part over here, this parentheses that you see here. Let me change actually color. So this is our input. This is what our method requires for it to function correctly. If it doesn't have that, it cannot function correctly. So these are the inputs that it requires for my main method to function correctly, right? And we'll talk about outputs and everything else a bit later. One other thing to note here, we'll need to utilize this keyword static, but we're not going to explain it yet. I feel that if we explain it right now, we'll just get confused by it. So for now, this we're going to ignore. We're going to ignore this, this, and this, and just talk about the name, the input, and the body. And then we'll come back to the rest. So how would this work? So first thing, I cannot create a method inside another method. So you could see here, this curly brace is the body, is the start, and you could see here is the end. You could see it being highlighted by the IDE when I put my cursor on it. So what we need to do is to make our new method right after it, right outside. So what we're going to do is right outside, but not outside of my class. We still need to be within our class. Here, I'm going to put some extra space so you can see. And we're going to say public. We're going to keep the same wording, static, void. And now we need to give it a good name. There are some rules for the naming, but we're just going to go with the convention, and you're going to learn about what you could do and what you can't do, like adding symbols and so forth, so on. What we're going to do and focus on is to make sure that the name of our method makes sense to the purpose of the method. Second rule is it's always have to be a verb. Every method is an action that we're doing. So actions require a verb to define what it's doing. And in this case, what we're doing is printing out the grade for every student. So we're going to start with a verb, print, students, it's plural, grades. We could plural that too. So our method is printing the students' grades. And that's perfect. Make it as long as you like. The IntelliSense will fill it up. So you could type in 2 letters and the IntelliSense will give you all of it. Well, after you typed it once. Now, we got a good name. What do we need as input for this to function? Well, for us to make this function correctly, actually, I'm going to just scroll down. Let's erase that little part over here. We got the name. We need the input. So we're going to put the input inside parentheses. These inputs are called a parameter. So we could have as many parameters as we want. Just divide them by a comma. So you can have as many as you want. These parameters are what our method requires for it to function correctly. In this case, for me to print the student grades, well, I need the grades. So what we need is an array. And we could just say grades or student grades or whatever you like. Having those grades, I could then print them. How would we print? Well, we already done it here, so we could go ahead and copy this and put it right there. Notice that when I do this, we'll get a few red errors, meaning these variables don't exist. Put your mouse over them and see what it says as an error message. This is important to get used to and having a habit of understanding what these error messages are and what do they mean. So cannot resolve symbol student grades. This is because student grades, the variable, does not exist in the context of this method. Where does it exist? Well, in the context of our main method. This is important. The moment I created it inside here, inside line 11, it will only exist within the boundaries of this body and not outside. It could exist inside an inner body, right? It could exist inside of an inner body because it was created right outside of it. But these two functions, these two methods are on the same level. So they can't see the other one. So here, we're not talking about students' grades. We're talking about this variable called grades. So we're going to do here, we're going to change that variable to grades. Oops. And over here as well. Now, this created a method with the name print student grades that takes a parameter, an array, an int array. We'll come back to this a bit further down. And the mini algorithm, the steps for it to function is we already done it before, which is a loop going through each element and printing that position and that grade. That's it. Do we need any output? No. Because right now, all we're doing is printing to the screen. Okay, great. But even though we've done this, we're not really utilizing our method. To utilize it, to call it, we'll need to call it by its name within our main algorithm. So within these boundaries, we need to do it. So what I'm going to do is, we could keep this one if we want, but what I'm going to do is replace it and say print, and notice the IntelliSense pop up. I'm going to press enter, and it needs an integer grade, an array of integers. So I'm going to pass it students' grades, and that's it. Now, if you notice, well, actually, first let's run it as always. Let's make sure our code works. How many students? 3. Let's say 5, 10, and 20. And notice that our code still functions correctly. If you look, this is our main body, all of that. But this extra bit of code, I don't really need to understand how it's being done, how it's coded, how it's running. I just need to make sure that, well, I need to trust whoever made it that it's going to function correctly, and it's going to do what the method name says, and it's going to take what it requires, right? So I give it what it requires, and it will do what exactly it says. Print student grades. Well, it needs the students' grades. It prints them for us. Now, the interesting part about this is when you create, if we go back a little bit, let's erase, let's go, can I doing a little bit of undo. If we go back, you'll remember the second step is to reuse our code. And we could reuse our code by any time by calling this method and passing it as many times as we want. So if we want to, we could call it 5 times. That 5 times, it's going to redo these steps every time. So let's run it. How many students? Let's say 3 again, just to make it easy on our eyes. Let's say 20, 50, 75. And notice what happens. For 5 times, it's going to repeat 20, 50, 75, 20, 50, 75, 20, 50, 75, so forth, so on. Right? One mistake that I see is you need to understand that until line 20 is not finished, line 21 cannot start. So even though this has a bunch of code in it, all of the stuff inside that body needs to be finished before we could move on to the next one. Cool? So this is good enough for an introduction to it. The last bit I want to talk to you about is, before we move on, is methods and function. Now, you're going to see this word, especially if you're going to continue in Java, they're going to be interchanged one in the other one. And most likely, you don't need to know more. This interchange is perfectly fine. But normally, we're going to talk about this a bit further, but normally in Java, there is only methods. Because there is no functions, the words are interchanged between each other. In a different language, let's say inside C++, these two, functions and method, mean 2 different things. I'm going to give you a quick definition of what they mean, and then we're just going to keep moving forward, but we're going to utilize the real word, okay? From now on. Methods and function mean the same thing in Java, because in Java, you can't have a function without a class, without an object. We'll learn about this later. But in C++, you could have a function without having a class. Those are called functions. When a function is within a class, within the body of a class, as you could see here, when a function is within the body of a class, it's normally called methods. It's a fine distinction, but in Java, you most likely will not see it. However, the better you know the terminology, the better you're going to be, the better people are going to understand you, the less mistakes are going to happen during this communication. So from now on, we're going to stick to methods. But again, might happen in your workplace that someone will interchange both of them. And it's okay. Don't get stressed. Don't give them a hard time for it. Maybe give them a reminder, but that's it, right? All right. I'll see you guys in the next video.